Okay, recording is started. So let's start officially. So good morning, students. This is a class of geotechnical engineering. We are discussing about module 2, part 2, that is CPS analysis. Okay. So till now in CPS analysis, we have discussed Laplace equation of two-dimensional flow. Okay. We also discuss about, or have discussed about velocity potential, stream function, and also at last flow net. Okay, so regarding flow net also we have discussed the basic things about flow net. That means what is flow net, okay, what is the significance of flow net, what is the properties of flow net, and what are the applications of flow net. Okay, so in the last class we have already discussed about the application of flow net. Okay, so basically or mainly you can say the flow net is used to study the seepage of water through a dam structure. Okay, so through a dam structure or any hydraulic structure which used to retain water in upstream phase, so it is required to study the seepage, or it is necessary to study the seepage analysis through dam for stability analysis of the dam structure. Okay, so for that you can also use flownet. That means flownet is one of the application using which you can find out details about seepage, details like exit gradient, okay, seepage pressure, hydrostatic pressure, and the total discharge through a dam structure in seepage. So in the last class we derived one equation for total discharge passing through a dam structure as flow or as seepage. And what is that equation? Q is equal to KH NF by ND. Okay, Q is equal to KH NF by ND. So let's show you that equation again. Let me first share my screen. So my screen is visible of right where I put that. Okay, wait. कहाँ गया? Oh, here. Okay, let me find that equation for you. Wait. I think this one, yeah. So this is the equation. Q is equal to KH NF by ND B by L. Now for square field, considering square field, you can assume B is equal to L. So finally we'll get this equation. This equation. Q is equal to KH NF by ND. This is the equation for total discharge or total seepage through a dam structure. Q is equal to KH NF by ND, where K is your coefficient of permeability, H is the head difference or total head due to which what seepage occurs. NF is stands for numbers of flow channel, and ND represents numbers of potential drop, total numbers of potential drop. Okay, so these things already discussed in the last class. So if you remember this diagram also, so the seepage, the flow net is used to study the seepage through dam structure. So here you can see the line diagram of a particular dam. This particular diagram also, I think it was described in the last class. So here it is the upstream phase. This is the downstream phase. Okay, this is a high full reservoir level. Okay, and from full reservoir level up to the top width, it's the freeboard. Okay, then the top flow line of the flow lines is known as phreatic line. Okay, and all are this is representation of the flow net. This all flow lines are parallel to the phreatic line, okay, and these equipotential lines are parallel to the upstream face of the dam, okay. So like this you can also draw this diagram if it needed, okay. So phreatic line or top flow line is defined as a line within the dam section below which there are a positive hydrostatic pressure exists in or within a dam structure. This is a basic definition of phreatic line, okay. Okay, these things are already discussed in last class, so let's discuss one numerical, okay, for now. Okay, let me find one numerical. Very small numerical here, you can see. Yeah. So here it is is one numerical here. Okay. So yeah, you can see the statement. Problem statement is given as what? For a homogeneous earth dam, 52-meter high and 2-meter freeboard, a flow net was constructed. The following results were obtained. Okay, that means there is a dam. Suppose there is a dam having a total height of 52-meter, and it also included uh, a freeboard of 2 meter. If you can remember the diagram, here also you can see the diagram. Small diagram is showing here. Suppose this is a dam structure. It is three-dimensional drawing is showing here. Okay, so this is a dam structure. Total height of the dam is how much? 52-meter, and the freeboard is 2 meter. Okay, this is the uh, information about dam is given. A flow net was constructed, and the following results were obtained. That means to study the CPs, a flow net was constructed having total equipotential drop, or total number of equipotential drop is given as 25. That is 25 numbers of equipotential drops are there, and that particular flow net having uh, 4 numbers of flow channel. Okay, so 4 numbers of flow channels are there and 25 numbers of equipotential drops are there. Regarding equipotential drop and flow channel, it is also discussed in the last class. I guess you have that idea about flow channel and potential drop. Okay, now the dam has a horizontal filter of 40-meter length at its downstream end. Okay, now what is filter? Filter is a particular component of a dam which is constructed at the bottom of the downstream face of the dam. Okay, it is constructed at such a way that it have a capability to divert or to attract, you can say, attract the flow line towards itself. That means if what phreatic line or flow lines is going through in this manner, okay, so it will divert or it can attract the flow lines toward its, so that the water or flow or seepage will flow through this, that means flow through the filter. By doing this, it will safeguard the downstream phase. Okay, fine. So yeah, calculate the discharge per meter length of the dam if the coefficient of permeability of the dam material is this much. It is 3 times 10 to the power minus 3 centimeter per second. So coefficient of permeability of this particular dam material is given as 3 times 10 to the power minus 3 centimeter per second. Okay, the value of K is given to you. Okay, now you need to find out the total discharge, that is Q. Okay, so to find out total discharge, you know the equation. What is the general equation? KH and F by ND L by B. Sorry, okay, or sorry, B by L or L by B. Let me check one more time. Wait. Sorry, B by L. Huh? So what is the value of Q? Q is equal to KH and F by ND B by L. Okay. Yeah. Okay. So since the value of B and L is not given here in this particular problem, the value of B and L is not given here. So to simplify the problem, we assume the particular flow net is having a square field. Okay, so you can also write nicely that assuming square field, So we can say for square field B is equal to L. So B and L will be cancelled out. Okay. So the general equation for discharge per meter length is given as Q is equal to KH NF by ND. Now what do you mean by discharge per meter length? So in this 3D diagram you will see per meter length means, so whatever you are seeing, this is a cross section. Dam is in this direction. The length of the dam will be in this direction. Okay. So up to 1 meter length only we are calculating the Q. Okay, fine. So Q is equal to KH NF by ND. Now value of K is given as 3 times 10 to the power minus 3 centimeter per second. Okay, fine. So next NF and ND is also given to you. What is NF? Numbers of flow channels. So NF is given as 4. ND, numbers of potential drop, is given as 25. So it will be 4 by 5 will be there. Okay. Now H. Now what is H actually? H, remember, H doesn't represent the height of the dam. H represents the total potential drop. That means the pressure difference. Now pressure difference means it is the height of the water, not the height of the dam. So don't be confused with this. Okay. So in this particular case, H is will be what? Total height minus the freeboard, isn't it? That means the height of the water. We need the height of the water only. So H will be 52, which is the height of the dam, minus 2, that is freeboard, height of the freeboard. So 52 minus 2 will be 50. So H will be 50 meter. Okay. So K is equal to what? 3 times 10 to the minus 3 centimeter per second. Let's convert in meter per second since other values are in meter. So okay. So K is equal to 3 into 10 to the power minus 5 meter per second will be there. So simply put the value here. K, put the value of K, put the value of H and NF by ND. Okay. So simply doing that, we will find out the value of Q. Okay. It's a very simple problem, but it look like complicated, but it's very simple. Although related to filter, it is not no used in this particular problem, but still it may given in the problem, but it is not used to find out the total discharge if you're using the application of flow net here. Okay. If you're going for graphical method or analytical method, then maybe the length of the filter may be used. Okay. But for now, you just need to know this formula only for solving the problem on uh, CPACE. Okay. So this is all about today class. I just want to introduce to you one basic numerical on this flow net. Okay. With this, I just want to conclude the module 2. Fine. Is it clear to you? So this kind of problem may come even in the MCQ also. So try to understand this kind of problem. In main part to understand the formula. Okay. I prefer you to understand the formula more than remembering the formula. Okay. So with this, I just want to conclude here. I'll just stop my sharing here. Okay. So till now, what we have discussed about in whole that module. Okay. So in whole module of that module 2, we have discussed that about permeability of soil, and in the part 1 and in part 2 we have discussed seepage of soil. Okay. So these two particular concepts are almost connected to each other. Okay. So I just going just revising your mind. Okay. So permeability is what? Permeability is defined as a property. Okay. Permeability is defined as a property of soil, where seepage is a phenomenon. Okay. Or you can say seepage is a occurrence. So what is permeability? Permeability is a property of soil which allow water or any fluid to pass through a soil mass through its interconnecting voids. Okay, and related to permeability, we come through a very important law, that is Darcy's law of flow of water through soil. Okay, and what is the Darcy's law of flow of water through soil? That is your Q is equal to KIA. Okay, Q is equal to, that is a discharge. The rate of discharge is proportional to the hydraulic gradient, and also the rate of discharge or unit discharge is proportional to the cross-sectional area of the soil mass. Okay, from that you will get Q is equal to KIA, where K is equal to coefficient of permeability. Okay, okay, one more thing I just want to share here. Let me share one more time. Yeah, let me go backward. So here you are seeing in this equation Q is equal to KH NF by ND. So this, it is written here the required expression for discharge passing through a flow net, and it is valid for isotropic soil in which KH equal to KY equal to K. Okay. Now there is a special case. Okay, that means whenever you are using this particular equation Q is equal to KH NF by ND, you are indirectly assuming that particular soil is isotropic. Now, what is isotropic means? Isotropic means the soil, whatever material the dam is having, the particular material, dam material having uh, equal or similar elastic property in all mutually perpendicular direction. Okay, that's why Kx, which is coefficient permeability in x direction, is equal to the Ky, that is coefficient permeability in y direction. When you consider isotropic soil. Sorry, yeah, isotropic soil. Okay, so if in some exam it is giving like anisotropic soil. Now anisotropic soil means it's a completely opposite of isotropic soil. So in case of anisotropic soil, the elastic properties of a particular material may not be same in all mutually perpendicular direction. So in that case, that value of kx may not be equal to ky or may not be equal to kz. Okay, that means in all three directions, the coefficient permeability may be different. So in that particular condition, you cannot use a one common K in that case. Okay, so for that you need to find out the average coefficient of permeability. Okay, if you are giving as an anisotropic soil, in a particular problem statement, there must be a value given for Kx and Ky. There must be given. If you are studying two-dimensional flow, if you're studying two-dimensional flow, then in a particular problem statement, the value of kx and ky must be given to you if it is a case of anisotropic soil. In that case, you have to find out average coefficient of permeability. Okay, and how can you find out average coefficient of permeability? I'll show you here. Let me take one pen. So average coefficient of permeability is what? Suppose I'm showing average. Okay, average coefficient of permeability equal to root over kx. Sorry, it's gone. What? Wait. So average probability K average equal to Kx multiply Ky. Okay, you just remember this. Okay, so average coefficient of probability for anisotropic soil K average equal to root over Kx into Ky, where Kx is your coefficient of probability in x direction, Ky is your coefficient of probability in y direction. Okay, is it clear? I think in some it is there in some uh, notes. Okay, let me check. So yeah, so this is a graphical method. So location of Friedrich line of an artered dam with field. I think these things also discussed in the last class. Not in detail. The graphical method is not discussed in last class because it no use in this particular semester. Okay, so it is MCQ based. I will share this video, share these notes also if you need. Okay, you can go through this. Okay, this is a line diagram of a dam. Okay, and this is a Friedrich line. Okay, so you can also determine the exact location of a Friedrich line by using a graphical method which is proposed by Casagrande. Okay, at least some very few points which is very necessary for MCQ based question. Okay, so Friedrich line can be located within a dam by a graphical method which is suggested by Casagrande, where Friedrich line is having a it takes a shape of a base parabola. Okay, so Friedrich line takes the shape of a base parabola. So in some MCQ, it may ask the basic shape of the Friedrich line or flow line. You can say the Friedrich line have a shape of base parabola. You have to remember this. Okay, and this graphical method is suggested by Casagrande. Fine, it's a very simple mathematical steps. Total 5 numbers of steps are there. Graphically, you can locate the location or exact point of the or intermediate point of a Friedrich line. And this particular graphical method is based on a principle of a base parabola. So for that, you have to go through the mathematics concept of base parabola. So for a parabola, what is a different component of parabola? This is a parabola. Suppose this is a part of the parabola. Okay, I'll show you one thing. So this is a shape of the parabola, isn't it? So let's continue this. Suppose this is shape of the parabola. So this is a line which called directrix. This is a line directrix again, isn't? This is a focus. Okay, fine. And this is a parabola. Fine. So what is the property of a proper principle of parabola or base parabola? So every point or each point on this parabola is equidistant from the focus and from the directrix. This is a basic principle of parabola. That is, suppose this is a point P on this parabola, the point is equally distant or equally spaced between or from directrix and from the focus. If you measure this distance PF and P whatever it is, suppose any point you can assume here, that means the point P is equidistant from the directrix and focus. Okay, so based on this basic principle of base parabola, the whole point can be located in within a dam structure. By this, you can find out uh, the exact location of a Friedrich line using graphically a graphical method proposed by Casagrande. Okay, you just go through this. So here some few points are there. Total 5 steps are given. Okay, you can also go for analytical method if you can understand the graphical method. It is very easy to understand the analytical method also. Same procedure. Okay, fine. Other things are not so much important for now. Okay, this is a problem that is already discussed with you. Okay. Which book should I use for this subject? Any recommendation? One. I think if you got the syllabus in a particular syllabus, also recommended books is already given to you. Okay, so I advise you to go through the syllabus. Okay, in the particular syllabus, it is already mentioned. You can for a beginner, uh, you can also go through that. What I can say, yeah, BC Punmia, soil mechanics, written by BC Punmia, and also you can go through any other book also. It there is no hard and fast rule for which book to refer. Okay, but personally I prefer BC Punmia. The book written by BC Punmia is for beginner of soil mechanics. It is very easy to understand at least. Okay, but BC Punmia is not enough for basically for soil mechanics, but for beginner it is okay. So you can refer that. ठीक है. So okay, other what? uh, MCQ based question. uh, okay, I will try. Okay, I think you have got some MCQ based question in even in the sessional exam also. Okay, so I think you have already got little bit of idea about sessional MCQ based question via sessional exam. Okay, if possible, I will also share, of course. Okay, so before that, first I have to complete all the syllabus. Okay, so with this, first let me stop my sharing now. Okay, I'm just going to close my recording. Okay, now I'm just taking my your attendance. I'm just closing my recording. Okay.